Ready to go. What is the common denominator of all of those? 3. Now, luckily, it all has a denominator, so you could do it by fractions, but I tell students just multiply through by 3 over 1. And, of course, you get 2x plus 4 is equal to negative what? 2. Now you can finish it. What do you do with that positive 4? Take it across the river. It becomes a negative 4. 2x is equal to negative 6. And divide by 2, what do you get? X is equal to negative 3. So you type in negative 3 right there. And you feel good about yourself. Now, let me go ahead and talk to you about something. What did we get for an answer here? You got a number, right? What if you don't get a number? Well, let me give you the rules for dang old solutions. And I call them solution rules. You're only going to get one of 3. 1 is an answer. X is equal to some number. Alright? When you get your variable is equal to some number, that's it. That's your solution. And you can take that number and do what with it? Plug it back in, and what does that do? Checks it. Yeah, it checks it to make sure it's right. Alright, 90% of the time you're going to get this. But sometimes you're not going to get it. Sometimes you're going to get x is equal to star, or x is equal to y, or negative 2 is equal to 27, or 5 is equal to negative 16. And all of these are what? Not true. So the first type problem, you're going to get x is equal to a number. The second type problem, you're going to get x, you're going to get something that is not what? True. Not true. If you get something that's not true, your answer is no solution. So if you work a problem out correctly and you get down at the bottom, 5 is equal to 207, and you've done everything correct, then the answer is no solution. Again, 10% of the time, you might get this one or the next one, number 3. The rest of the time, you're going to get this one. So you got to watch out for them. This is also called a contradiction. Write that down. Contradiction. That's a 25-cent word for no solution. Contradiction. When something is not true, it's a contradiction. And the last one is when x is equal to x, y is equal to y, 2x plus 2 is equal to 2x plus 2, 4 is equal to 4. What are those? Well, if these are not true, what are these? True. And you get a true statement. Your answer is all real numbers. And this is called an identity. So if you get something that is true, 5 is equal to 5. 2x plus 2 is equal to 2x plus 2. 3 is equal to 3. X is equal to x. 4 is equal to 4. If you do a problem and you do it all correctly, and you get down to the bottom and it says 4 is equal to 4, then your answer is all real numbers. That means any number that you plug in for x will come out true. That's what that means. So 10 to 15% of the time, you're going to get these type problems. And then 90 to 85% of the time, you'll get these. And that's why in the previous question, you got this. There is one solution. X is equal to a number. The solution is all real numbers, which means a true statement. The equation has no solution, which means an untrue statement. Let's do a nerd. Feel good about that one? Yes, Hubert. No, Hubert. Glad y'all interacting. It's always good to have a class and interact. Oh, okay, it's my fault. Yeah. All right, here's one. We got to clear the decimal. You were planning on talking today, right? 2.6x minus 11.22 is equal to 6.2. 2.6x minus 11.22 is equal to 6.2. Now, what decimal value is, what decimal point is being used in this problem? The furthest one. The tenths or the hundredths? Hundredths. We go with the smallest. So hundredths is smallest. So I'm going to multiply through the whole thing by 100. So do that. So that means you're going to move the decimal 2 places to the what? Right. So that'd be 260x minus 1122 is equal to 600 what? 20. Now you've got nothing but whole numbers to work with. And some of you like that. So take the 1122 across the river. And that gives us 260 is equal to 1742. When did Columbus discover America? 1642? So this is 100 years later. I can't remember. When did what? 1492. I knew there was a 2 in there somewhere. Okay, well this is 300 years later. All right. Divide by 260. Divide by 260. And we can divide both of those by 2. X is equal to 2 will go into 17. That's 130 on the bottom. And 2 will go into 17 8 times. 1, that's 7. And 1. 871 over 130. I'm going to let y'all work on that. I don't think you can reduce that down anymore. I mean, decimal-wise you can. The directions say type it as an integer or a decimal. So somebody print that out on the, I'm sorry, say again? 6.7. So you type that in. It doesn't say round. Give me the hundredth because we do have a hundredth up there. So what would the hundredth be if you rounded? 6 point what? No, the hundredth. Give me the second one. Does anybody have it on their calculator? Is it just put 6.7?
That's what I just showed on mine.
You got it right.
Yeah, it's exactly 6%.
You are a winner.
Yeah, I am.
Whatever. All right, next one. Okay, that's not a test question. That's an easy question. There you go. There's a test question. It says x over 2 plus 3 over x is equal to 1 over 5. And if you get confused, make everything a fraction. X over 2 plus 3x over 1 is equal to 1 over 5. What is the common denominator of 2, 1, and 5? 10. So I'm going to multiply through by 10 over 1. Put a baby step in there for you. 10 over 1. So 10 over 1, 10 over 1, 10 over 1. And I'm going to multiply through by x over 2, 3x over 1, 1 over 5. And put parentheses, that means we're multiplying. And take my purple marker. What happens to the 2 and the 10? And that's a 5x. Plus, what's 10 times 3x? 30x. And then 5 and 10 is equal to what? 2. And then what's 5x plus 30x? 35x is equal to 2. And divide by 35. And your answer is 2/35. Piece of cake. 2 over 35. See, like I said, most of the time your answers are going to come out to a number. All right, try that one. This one says 12 times x plus 4 is equal to 3 times 4x plus 3 plus 39. Okay, what's the first thing we do? Distribute, Hubert. Thank you, class. Now it'll give us 12x plus what? 48. Thank you. Is equal to 12x plus 9 plus 39. 12x plus 48 is equal to 12x plus what? Oh my gosh. What do we have? What? Is that a true statement? Then what is it? True statement means what? And what does that mean? That means that any number you plug in for x, that's going to give you what? Okay, let's try it. Pick a number. 0. 0 plus 4 is what? 4 times 12. 0 plus 3 is? Last time I checked, it was 3. 3 times 3? 9 plus 39? Pick another number. 6 plus 4? 10 times 12? Might as well do his calculator. 120. 6 times 4? 27 times 3? 81. 81 plus 39? Same thing. That's what it means. And you feel good about yourself. And what is this called? Identity or contradiction? Identity. Contradiction is when it's not equal. Try to find one of those for you. But I don't know if they put one in here or not. All right, there's your test question. This one says 2/3 times x minus 5 is equal to 3/5 times 5x minus 3. Now, either you can get rid of the fraction, or you can distribute it and get 4 more fractions. I think I'd rather clear the fraction. What's the common denominator? 15. So I'm going to multiply by 15 over 1. Put a baby step in here for you. And what's 15 divided by 3? 5, and 5 times 2 is, I don't know about you, but I'd much rather deal with 10 than 2/3. 15 divided by 15 divided by 5 is 3. 3 times 3 is 10x minus 50 is equal to 45x minus 27. And I'm going to take that 10x over, and that'll leave me with 35x on the right. Bring that 27 over, and what's negative 50 plus 27? Dang old 23. Dang old negative 23. Negative 23 over 35, but check my math. Hoping I'd get no solution. We'll keep going till we find one. Negative 23 divided by 35. That gum. Yeah. don't give you too many applications, do they? Thought they'd give a whole lot more than that. And that's it. Now, I'm going to skip a bunch of sections because I want to get you, we're going to keep doing what we're doing, solving them, and we're going to skip to, hold on, 5, I'm not in chapter 5, am I? 6, thank you. We're going to skip to, hold on, I think it's 6.5. Should be inequalities. Is it 6.5? Okay, 6.6. Okay. We're going to skip to 6.6. And a lot of people say, why are you skipping so many sections? Well, they're teaching you the same thing. I'm teaching you how to solve equations, and you do the same thing in inequalities. I don't want to start 6.2 and then we go do some other stuff, and then you forget how to do 6.2, and then we go to 6.6, and you go, okay, how did we do that? So I'm teaching it at the same time because it's the same thing. 6.6. So we're going to skip from, what was that, 6.2? From 6.2 to 6.6 because 6.2 is solving equations. And 6.6 is solving using the same thing you learned in 6.2, but it's going to be inequalities. Okay? The solving part is the same. And that's why I'm going to 6.6, so you can remember how to do all that problem solving or solving for the variable. All right? Now, the difference between these two is an equation has what? An equal sign. An inequality does not have an equal sign. It has one of these 5 guys, one of these 4 guys. It has one of these, or it has one of these. Now notice I didn't call them names. I just said one of these and one of these. I despise it when teachers go, this is less than or this is greater than. You don't know because that's like saying the and then are the same if you don't have it in a sentence. How do you know whether you use the or there or the or then, or how do you know if you don't have words around it? What do you know? How do you know what word to use? How do you know this is greater, less than, or this is greater than? You don't have any numbers on the side. I could go 2 is greater than 3, and 3, I'm sorry, 2 is less than 3, sorry. I can't count. 2 is less than 3, or I can say 3 is greater than what? 2. Are both of those the same? Yes. 3 is greater than 2. 2 is less than 3. 3 is greater than 2. 2 is less than 3. Doesn't matter which way it's pointing. It matters the quantity of the number on each side. Okay? Saying this is greater than or this is less than is like saying Johnny and Susie have to sit on one side. Johnny has to sit on the left side of the seesaw, and Susie has to sit on the right side. And if you go to another park, they can't switch sides. They have to stay on the left side of the seesaw and the right side of the seesaw. That's ridiculous. I could put 2 over here and turn it this way, or I could put 2 over here and turn it this way, just like the equals. Okay? So I don't want you to call these any certain thing. I want you to just list them like I have, and just after you put them in a sentence, then you can say greater than or less than. Now, let's go ahead and write some rules for these two guys. The rules for these two guys, and let me color everything black. Okay. The rules for these two guys is that whenever you deal with these two guys, whether it be on a number line or a graph or whatever, you're going to write these in terms of an open circle and parentheses. Okay, so it's going to be an open circle or parentheses. And anytime you deal with these two guys, whether it be graphing or whether it be interval notation or however you write your answer, not an open circle, but a what?
Closed circle.
Closed circle. And instead of parentheses, what are we going to use? Brackets. Now this is what you have to remember for this chapter. Because the solving is the same. You're going to solve the exact same way that you solved in 6.2. The only difference is, in this unit, one, you're going to get an answer. That's the same as 6.2. Okay, you're going to get an answer. The second thing you're going to do is you're going to graph it on the number line. And the third thing you're going to do is you're going to write it in set builder notation and interval notation. You're going to rewrite your answer. Okay, so this is what you did in 6.2. You got your answer. Now in this section, you're going to graph it on the number line and you're going to write it in set builder notation and interval notation. Now, what's our two objectives in algebra? The first one is to get the variable what? By itself. The second is to try to keep the variable what? Positive. Because if you keep the variable positive, you will not have to remember the two other rules, dividing through by negative and flipping the inequality. So let's write that down. The first rule, or the first objective of algebra, is to get the variable by itself. The second objective that we like to do, or try to, is to keep the variable positive. So let's look at an example and let's see what we need to do. 2x plus 4 is greater than or equal to negative, no, I'm going to put 5x minus 2. Alright, now I want you to solve that. And then I want you to try to graph it on the number line. I'm not going to ask you to do the last two because chances are some of you, unless you've had algebra before, do not know what interval notation is and builder notation. I was hoping it would rain all day today. All right, am I going to move the 5x to the left or the 2x to the right? I'm going to take the small bucket and I'm going to move it over here. And that'll give me a negative 2x. And then I'm going to bring the negative 2 over here. And that'll give me 6 is greater than or equal to 3 what? Divide by 3. Divide by 3, and x is less than or equal to what? 2. Now, before, in 6.2, we called our answer a solution. Right? In 6.6, we call it a solution set. Why do we call it a solution set? Why do we not just call it a solution? Because what? Yeah, why are we going to graph it? Yep, that's right. That's how you graph it. But why? Why do we graph it? And why do we call it a solution set instead of a solution? What? There's more than one answer. What does this say? It says x is less than or equal to what? 2. That means that any number less than 2 will work in this equation. Now you got to know what less than 2 is, because sometimes y'all get kind of crazy when it comes to negatives. Y'all don't know what less than or greater than is. Less than 2. So that's why it's easier to graph it. So I'm going to take my answer. X is less than or equal to 2, and I'm going to put it on the number line. X is less than or equal to 2. And yes, that's the same thing. I just took Jody and Susie and I put them on the opposite sides. There's no law that says you can't put an X on the right hand side. There's no law that says you have to put it on the left hand side either. So, draw my number line. 0, -1, -2, 1, 2. This is positive infinity. And what is this one? That arrowhead is called negative infinity. Now, what kind of circle are we going to use? You said it a while ago. What kind of circle? Closed circle on 2. So I draw a closed circle on 2. Now, what numbers are less than 2? Everything to the what? To the left. You take your shader or marker and you highlight those numbers. Okay, that's how you graph your solution set. Now, which way do we read? Left to right. Left to right, unless you're from the Middle East, Masalama. If you're from the Middle East, you read from right to left. So, unless you're from the Middle East, most of us read from left to right. So, how do you read your solution set from left to right? What's that called? Negative infinity to what? To 2. So, negative infinity to 2. And a lot of people say, why'd you stop at 2? Well, where does the shade stop? At 2. Well, wait a minute. Can we ever touch infinity and negative infinity? No. So it always gets a parenthesis. Infinity, whether it's negative or positive, will always get a parenthesis because you can't what? You can't get to it. Okay, so it gets a parenthesis. What do we put on 2? A closed circle, right? What does closed circles go with? Brackets or parentheses? So the 2 gets a what? Bracket. That is called interval notation. Interval notation is when you use the brackets and the parentheses. Set builder notation, and this is the one that most algebra teachers use. Interval notation. And make sure you know the difference, because a lot of entry exams or standardized tests ask you to write something in interval notation, and that's how you do it. And it's always helpful to graph it first, and then you can Read it from left to right. Set builder notation is real easy. Set builder notation, you draw two braces. You put X such that, that's set builder notation. And then you put your answer right there. X is what? Less than or equal to 2. And that's how you do set builder notation. And that's set builder notation. Now, the solution set. What does that mean? That means that any number in this group will work in the original equation. Somebody pick a number in the shaded group. I'm going to pick 0. Why would I pick 0? Easiest. Okay? So let's go back to the original problem. 0. What is 0 times 2? 0 plus 4 is 4. What is 0 times 5? Minus 2? Is this true or false? And any number that you get in the shaded region will give you a true statement. So you could pick negative 100. So let's pick negative 100. Negative 100 times 2 is negative what? Negative 200 plus 4 is negative 196. Negative 100 times 5 is negative 500. Negative 500 minus 2 is negative what? No, negative 502. Negative 500 minus 2. You owe 500, you owe 2. What's the outcome? You owe 502, you don't owe 498. Is negative 196 greater than or equal to negative 502? Yes. What would you rather have in the bank? Would you rather have negative 196 or negative 502? Negative 196, because you only owe the bank $196 versus negative 502. Yeah. Mine is like that all the time. I don't know what I'd do without overdraft. All right. So, now you see why I put these two sections together. I put them together because you already know how to do this. And I don't want you to forget. So, I want you to do 6.2 and 6.6 together. So, let's go ahead and do a nerd. And just leave. Get mad and leave. Okay, that's fine. I don't blame you. I'd get mad too. See ya. All righty. .6, and let's pull up some problems. I'll pull up some test problems. Okay, don't want to do that one yet. Let's do a simple problem. Okay, let's do this one. This is a simple one. This one's 5x plus 9 is less than 34. 5x plus 9 is less than 34. Is the variable positive? Yes. If it ain't broke, don't fix it. So leave the 5x alone. So take the 9, cross the river. And we get 5x is less than 34 minus 9 is 20 what? And x is less than 5. What kind of circle are we going to put on 5? Open circle. So that means this guy is not it. And this guy is not it. Which one is less than 5? D. So that's greater than. This is x is greater than 5. So that's not it. So your answer is D. Is that a test question? No. I mean, you might get one like that on the test. That's just something to start you off with. All right, let's try nerd. All right, that's a test question. This one says 5 times 2x minus 1 is less than or equal to 2 times 5x minus 4. So what are you going to do with the 5 and the 2? Distribute it. And distribute this one. No yawning. 10x minus 5 is less than or equal to 10x minus 8. What happens to the 10x's? And you get negative 5 is less than or equal to negative 8. Is this a true statement? Well, let's ask the question. What would you rather have in the bank? Negative $5 or negative $8? Negative 5. So negative 5 is greater than negative 8, correct? So is this a true statement? No, it's not. So take your red marker. And if you get an untrue statement, what's your answer? No real solution. So which one depicts no real solution? Yeah. So we did find a contradiction, didn't we? And that's your contradiction. It just didn't have an equal sign. The equal sign would have been 5 is equal to 4. And then you would have marked through it and said contradiction, no real solution. And we feel good about ourselves. Okay, look at that one. This one you don't have to solve. And yes, it is a test question. You don't have to do anything. All you have to do is graph it. Somebody will mess it up. It says negative 3 negative 3, let's try it again. Negative 3 is less than, x is less than or equal to 3. And they want you to graph it. Zero, negative 3, positive 3. What's going to go on negative 3? An open circle. What's going to go on positive 3? And what numbers are between 3 and negative 3? Well, you can just do it yourself. It would be right here. So you've got to find a graph that's closed, shaded, open, shaded, closed. Open, shaded, closed. Nope. Open, shaded, closed. Nope. Open, shaded, closed. Nope. So A is your only answer. That's a test question because you don't have to do anything but think. You don't even have to solve it. It's already solved for you. Okay, now this one, you do have to solve it. You want x by itself. This one says negative 8 about ready to give up. Negative 8 is less than x plus 5 less than 8. Now there's only one thing you've got to get rid of, and what is that? 5. How do you get rid of a positive 5?
Subtract 5.
And wherever you subtract it, you have to subtract it where else? On the other side. I subtracted it from the middle, so that goes out. And negative 8 minus 5 is what? Negative something. I can't add 8 very well. Negative 13 less than x less than 8 minus 5 is. So what kind of circle is we looking for? Open on both ends. So that's going to be open on both ends. So that way this one is what? C is wrong. Because C has what? Closed end. And we know that x is between negative 13 and 3, so it's going to be open, shaded, open. So all of these are open, shaded, open. All of these are. But different numbers. So we need to find negative 13 and 3. Negative 13, nope. Negative 13, nope. So your only answer is D. What am I trying to tell you about the multiple choice problems? Law of what? Deduction. Somebody's going to look that word up. Next one. No, that's not a test question. That's not a test question. Those are too easy. Okay, I need to show you what these are. Go ahead and write this problem down. I want you to write it down and highlight the word integer. Graph the solution set of the inequality where x is an integer. What does the word integer mean? What? I heard it. Whole number. Integer is a 25-cent, hold your pinky up, word for what? Whole number. Now, our variable is negative. I'm going to put it on the other side because I don't like to deal with negative variables. So I'm going to put this on the other side and it becomes a what? positive x over 7. I'm going to put this on the other side, and it becomes a what? Negative 2, Hubert. That's right, class. So, negative 2 is greater than or equal to x over 7. Now, what do we do when we have fractions? Clear them by multiplying through by the common what? So I'm going to multiply through by 7 over 1. And when I do that, what's 7 times negative 2? Negative what?
Negative 14.
Negative 14. Greater than, equal to. And the 7's cancel, and you're left with x. So x is less than or equal to negative 14. What kind of circle we need? Need a closed circle. Are all these closed? Yep, all of them are closed. So we can't deduct anything there. Negative 14. Well, this is negative 14. That's negative 14. That's negative 14. And that's negative 14. So all of them are started at negative 14. What numbers are less than negative 14? To the right or to the left? To the left, because they're less than. So what numbers, what about this one? Is this one to the left or to the right? So that one's wrong. This is a possibility. Is this one wrong? Yep. And this is a possibility. Because these are left, and these are left of what? Negative 14. Yeah, but that's a closed circle. Closed circle, all of them have closed circles. So equal to is a closed circle. Now, what was that? My next problem is, which is the answer? Nope, you're wrong. You need to leave. The reason this is not the answer is because these are all numbers. Fractions, decimals, and whole numbers. What do we want? Whole numbers. So your answer is D. That's why you have these big dots on just the what? The whole numbers. You need to make a note of this, because this is a test question and it's in your homework, and a lot of y'all don't understand it. This is why. When you want to just mark the integers, you use closed dots on each integer like this. The shaded region means decimals and decimals and fractions and whole numbers. That's what the shaded arrow is. So that's not the correct answer. That's just find the solution set. This is just find the solution set. This is find the solution set in regards to what? Whole numbers. That's why the dots are there. So you need to make a note. This is your answer because it's asking for just the what? The whole numbers, yes. So D is your answer. That is a test question. All right, I'm going to let y'all do this one. All by yourself. It says, eight times x plus 5 minus 24 is less than or equal to 5x plus 7. So do that one. Lucency slider. I don't know what that is. Fruit. Okay. All right. So, first thing you do is distribute the 8, just like you learned in 6.2. And you get 8x plus 40 minus 24 is less than or equal to 5x plus 7. And 40 minus 24 is dang old 16. 8x plus 16 is greater than or less than or equal to 5x plus 7. Am I going to move 5x over or 8x over? 5x over, and that becomes 3x is less than or equal to, we'll take the 16 over, that's 7 minus 16 is negative 9, and x is less than or equal to what? What kind of circle is going to be on negative 3? Closed. Negative 3. Closed. Negative 3. Closed. Negative 3. Closed. Negative 3. Closed. So they're all right as far as negative 3. What numbers are less than negative 3? To the left or to the right? To the left. So this one's not right. This one's not right. Which one is it? D or A? It's D because A means fractions and decimals, and this says what? Integers, which means whole numbers, so it gets the dots. Question. And that's a test question also. That one you multiply through by 10. That one takes care of itself. I'm going to let y'all work on that one. Not right now, but. All right, let's look at this one. It says, and this is a test question, Chris can be paid in one of two ways. Plan A is a salary of $320 per month plus a commission of 9% of sales. Plan B is a salary of $620 per month plus a commission of 4% sales. That would be mine. You know why I would go with Plan B? Because I couldn't sell an Eskimo heater. I am not a retail person. Okay? So that's why I would go with Plan B. Plan B is for the people that don't know how to sell anything. All right. For what amount of sales is Chris better off selecting Plan A? So which one's better off? Which one does he want to see is better off? Read the last sentence. Plan A, Hubert. That's right, class. So it would be Plan A greater than Plan B. Why not equal to? He don't care about breaking even. He wants to know when Plan A will be better. So that's what he wants to know. He don't want to know better than or equal to. He wants to know better. So figure out a formula for Plan A and Plan B, or equation, and then set Plan A greater than Plan B. 320 per month, so that'd be times what? M, plus 9%, 0.09 of what? Sales. I'm thinking out loud right now. That's what I'm doing. Plan B, that's plan A. Plan B says 620 per month plus 0.04 sales. Now, we don't care about the month because they're not giving us anything about months. So you can take the months off and just say 620. So they want it by month. So you can say 620 and 320 plus percent sales. And you can say S is equal to sales. So plan A would be 320 plus 0.09 S is greater than 620 plus 0.04 sales. Now, solve it. And you can use a calculator because there's no sense in clearing it because you'll just get big numbers. So you can use a calculator on this one. Am I going to move the 9S or am I going to move the 4S? I'm going to move the 4S. And I don't care about the numbers. The numbers will work out. I just don't want my variable to be negative. Bring 0.04 over. What's 9 cents minus 4 cents? 5 cents. Greater than 320. What's 620 minus 320? Divided by 0.05. Somebody give me that number. 300 divided by 0.05. Say again. I didn't hear you. 6,000. So when is plan A greater than plan B? When you sell how much merchandise? $6,000. Anything after $6,000, plan A is better than plan B. So if I sold $5,000 worth of stuff last year or last month, should I go with plan A or plan B? Plan B, because I'll make more money than if I chose plan A. But if I sold $7,000 worth of merchandise, then I want to go with plan A because I'll make more money. And that's usually how you use inequalities. Inequalities are used a good bit in business. A good bit. Okay? All right, let's try that one. We'll finish on this one. While y'all are writing it down, I'll get the roll. It says a student must have an average. Where's my? Okay. A student must have an average, the mean, on 5 tests that is greater than are equal to 80, so 80 greater than or equal to x greater than or less than or equal to, no, less than 90. So it'd be 80 less than or equal to x less than 90 to receive a final grade of B. Devin's grade on the first 4 tests are 80, 63, 91, and 80. What range of grades on the 5th test will give him a B in the course? So work on that. Pull up my handy dandy attendance tracker. Alright, we only got, what, 1, 2, I think I'm just going to hit, well, I think I'll just hit no. I think that'll be easier. Alright, Miss Bailey is here. Let's see if I can get everybody today. Miss Bailey is here. Miss Beasley. I don't think Miss Beasley's here. Clemenshaw. I don't think they're here. Corral. Dizdar. Flannery is here. Granger is not here. Hayes is here. Lassiter is here. Richardson is here. Rochester is not here. Satterfield is here. Tatum's not here. Walker is here. Okay, who did I leave out? Your last name. Okay, Clemenshaw. Well, I did pretty good for everybody but one. Yeah, I got everybody. Alright, so that's done. Alrighty. Alright, so the way you set this one up is you've got to remember that you can't just say 80. You have to say 80 times what? 5. What's 80 times 5? 400. So 400 less than or equal to 80 plus 63 plus 91 plus 80 plus blank is less than, and what's 90 times 5? 450, Gilbert. Thank you, class. So add all these up. 80 and 80 is 160. 160 and 100 would be 260 minus 9 would be 251, right? 251, that'd be 311. Somebody help me out. 400 less than 311, x plus x, sorry, is less than 450. Somebody check the middle, see if you get 311. Okay, 314, thank you. Is it 314? Is that what y'all got? 15 minutes later. Anybody else get 314? You got it? Okay. Minus 314. Minus 314. So our grade needs to be between what? What's 400 minus 314? They go 86. Yes, no, maybe. And what's 450 minus 314? Dang, 146? I don't know. 136?
Shouldn't that answer the 455, so it would be 9190 and add extra 5.
What, this right here?
So the very end.
No, 90. What's 90 times 5? Okay, what did this come out to be? 136. All right, my answer is 86 less than x less than 100. Why does I say less than 100? Because you don't make a what? You don't make 136 on the test. Yep. So he needs to make between 86 and a what? 100. The 91 goes in the middle. All right. Now what I would like for y'all to do is I want you to work on 6.1, 6.2, and 6.6.